Bismillahirrahmanirrahim. Welcome to my channel. And we are still in isolation, and schools are closed till further order. And we are combating this COVID-19. And the message, as I gave last time, is the same, that the virus does not move. People move it. We stop moving, the virus stop moving, the virus dies, and it's that simple. So we have to be isolated, we have to be quarantined and distancing. Social distancing is the order of the day. So come back to our topic. Kids are at home and maybe practicing exponent lessons. For grade 8 and grade 9, it is important. It starts from grade 8. In the last part, we did the two rules of exponent, product rule and quotient rule. Now we will be learning all of the rule together and do some exercises. So the third rule is power rule, which says that power to the power of a variable of any number can be multiplied. If I have 2 to the power 2 and another power is raised on it, right? So now the power and the power to the power. So the power to the power is getting multiplied. So 2 times 3, that means it means 2 to the power 6. And 2 to the power 6 means 2 is multiplied by itself 6 times, right? 6 times, 1, 2, 3, 4, 5, 6. And then you multiply to get the number or to get the solution. 2 times 2 is 4, 4 to the 8, 8 to the 16, 16 to the 32, 32 times 2 is 64. This will be your answer to this example. So similarly, if you have fraction rule, so if this anything is written like this, 2 over 3 to the power of, for example, 3. So it means everything, numerator and denominator, has got this power. If it's on the parenthesis, that means the fraction rule is if something is in fraction, 2 over 3, or something 5 over 7 or whatever. So if you have an exponent on the parenthesis, then that means that each number in the numerator and denominator has got that power. So that means 2 to the power 3 in the numerator and 3 to the power 3 in the denominator. So you multiply with each other and then you will see 2 to the 4 times 2 is 8 and 3 3 is 9. 9 times 3 is 27. And your answer is 8 over 27. So now third one, overall is fifth one, the product rule, power of product. So if two numbers are product, right, inside the parenthesis, they are multiplying with each other, but there is a power on top of the parenthesis. That means 2.3 to the power 3. That means each of this number has got the power. So that means 2 to the power 3 times 3 to the power 3. And which we need to solve will be 2 to the power 3 is saying 2 times 2 times 2. And 3 to the power 3 is saying 3 times 3 times 3. And then we have to solve them and multiply. So 3 times 3 times 3, 3 3 is a 9, 9 3 is a 27. 2 times 2 is 4, 4 times 2 is 8. So you have to multiply 8 times 27. And then you multiply 8 times 7 is 56, carry 56, carry 5. 8 times 2 is 16 plus 5 is 21. So you got 216 as your answer, right? So now move on to the next rule. So this is zero exponent rule. Zero exponent rule is anything, any number, any alphabet, any expression raised to the power 0 is equals to 1. So there is no limitation. If it is x to the power 0, it is 1. If it is a to the power 0, it will be 1. If it is a plus b raised to the power 0, it will be 1. If it is x divided by to the power 0, it will be also 1. Any number, any expression, anything, 4320 to the power 0, it is 1. So any number raised to the power 0 is 1. So this is the zero exponent law or rule. Negative exponent rule, this is important. We will be dealing some more examples on each of them. So a to the power negative x. So if I have something x to the power minus 4, and question is saying I don't need negative exponent. So what is the rule here? That this will go into the denominator from the numerator to denominator, and it will be getting its power positive. So a to the power minus x is equals to 1 over a to the power x. So if you need to change this negative power, you just bring it from numerator to the denominator. And same is true for the vice versa. Like if it is x to the power minus 5, let's say in the denominator, and you don't want to see this negative power in the denominator, so you have to bring it up and it will change its power. So it was in a denominator negative 5, but if you shift it to numerator, it becomes positive. So this is called negative exponent rule. So negative exponent rule. If the power is negative, you can make it positive by making it reciprocal, or by shifting it from numerator to the denominator or denominator to the numerator. Another interesting rule is here, which is a to the power of the fraction. So anything, for example, I say 4 to the power 3 over 2. It's like the same exponent fraction, a 4 to the power of 3 by 2. What it's saying? It's saying that this number, the top, is the power of the number or variable. So my 4 has got a power of 3, but I have the square root, and this y will come here. So this is this, which is half root, right? Square root. So this is here the square root or radical sign, and 4 times 3, 4 to the cube, right? 4 to the cube means 4 times 4 times 4, and that means 4 times 4 is 16, times 4 is 64, and if you take the square root of 64, because it's a half power, so you will say 8 into 8 is 64, and then you take half power, that means 8 is your answer. So here is your answer, 8. So understand this fully. Any number raised to the power of fraction x over y. The x is the power of the variable or the number. So here is the example, 4 to the power 3 by 2. So 3 is its power, but 2 is its in the radical sign. Right? We can take another example of this kind so that we are sure that what we are doing is correct. So let's take another example here for this fraction rule, fraction exponent rule. So let's say anything like 2 to the power 5 over 3. Now there is a fraction on the top, right? So what the rule is saying, that this power 5 goes with 2, but this 3 will here. So it is the cube root. We have to take the cube root of whatever inside is. So we have to take 2 times 5 times, right? 5 times it will be getting multiplied by the definition of exponent, and then we have to take cube root, right? So cube root means it's not the perfect cube root because there is no third 2, right? So that means we have to calculate it, cube root by calculator maybe. So 2 to the 4, 4 to the 8, 8 to the 16, 16 times 2 is 32. And if we take cube root of 32, it's approximate 3.17. This is my answer, right? So this type, so we cover all of the exponent rule. Product rule, we will revise it. Product rule, if the base is same, exponents or the powers can be added. If the base is same, the rule is same for, like all the rules have got the base same. So base same, powers can be subtracted if they are in the quotient. Power rule, power to the power is getting multiplied. Power to the power getting multiplied. So we have this example here, right? So we did this example as well. Power to the power. So a to the power x to the power y. right? A to the power. So 2 to the power 2 to the power 3. Power to the power will get multiplied. We have this example here. Fraction rule. If something is in fraction and whole power is there, this power will count on both numbers or both variables. So 2 over 3 exponent 3, this will be 2 to the cube divided by 3 to the cube, and then you solve the equation. So we will revise it in some more detail, in some more examples here to understand fully what these rules application is. So these were the examples just to understand that what the rule is saying, the simple example in math to understand the rule, but it can be applicable. These rules are also like for algebraic expressions as well. So if we have anything like x to the power minus 2 multiplied by x to the power minus 6 multiplied by x to the power 4. Let's say it's a simple example. It is a multiplication, base is same, and what my rule is saying that powers to be added or subtracted. So 2 minus 6 plus 4. These are all the powers of x. So I have to say, so minus 2 minus 6 is minus 8 plus 4, right? So now x to the power minus 4. But I don't want to see minus 4 in my answer or in my variable. So I have to shift it to the, according to this rule, negative exponent rule, I have to shift it to here. So my answer is, so I apply two rules here. One rule was saying that, okay, if the base are same, the power can be added or subtracted. So I add or subtract the powers. Finally, I had a negative power, but negative exponent rule says that if there is a negative power, you can shift it to the denominator to make it positive, or vice versa. So this is my practical example or application of now example 2. Maybe we have something like the same. Z to the power minus 8, let's say, make it any example to understand. So z to the power minus 8, by this negative exponent rule, it's saying that it will go and make positive. You can do it with this method, or you can do it with the first one, because first one is saying that if the base is same, powers can be added or subtracted. So whatever is going on here, that will give me z to the power minus 5. And I will apply now the negative exponent rule, which is saying that, okay, if you have something in negative power, you can shift it from the numerator to the denominator to make it positive power. This is my answer, right? I can take another example maybe. So if you have 2x cubed to the power 2, now this is here, that power to the power. Power to the power is right here, power rule. So power to the power being multiplied, right? And it is on everything which is there. Why everything means if it is on A and B. So if it is on 2, it is saying that 2 to the power 2 and x to the power 3 times 2. Two rules, right? Because one of the power product rule is saying that if anything, two things has got the power, then everybody has the power, as that power. So 2 has got the power and 3 also has got the power, but 3 will be power rule. So 3 times 2 is 6. So my next step will be 2 to the 4 and x to the power 6. This will be my answer for this example. I take another example now. So maybe now it's saying x to the power 8, x to the power 0, x to the power 12. What is happening here? I will apply now the zero exponent rule, and zero exponent rule is saying anything raised to the power 0 is 1. So here is my example. Here I have x power 8 times 1, because x to the power 0 is 1, divided by x to the power 12. And here it says my negative quotient rule, that if it is dividing, I have to bring the denominator power and get it minus, right? This exactly same, a to the power x minus y. And here when I do this, I am left with x minus 4, x to the power minus 4. But this is not recommended that I have a negative power, so I have to shift it by this negative exponent rule to the denominator. So my answer is 1 over x power 4 this time. Now take another example, maybe number 5. So maybe what we can take 2y power 4 over 4y to the power 2. So if this is my question, so according to the rules which we learned, 2 to the power 2, y to the power to the power multiplied, 4 times 2 is 8, 4 to the power 2, y to the power 2. Now this will be giving me 2 to the power 4, 2 to the power 2 is 4, y power 8 will remains for time being. 4 to the power 2 means 4 times 4, which is 16, and y square. Now what I can do is 4 and 16 get cuts with each other. 4 4s are 16, so I have 1 over 4, and I have y power 8, and then quotient rule. Quotient rule is saying the power will get subtracted. So power will get subtracted means 8 minus 2, and that will be giving me 1 over 4 y to the power 6. So this is how we can carry on our examples. Hope you understand all of these. So just review them, and hope you like the video. If you like it, subscribe my channel, press the bell icon button. Thank you for watching.